So for question B, I have no idea what this looks like. And this might send you kind of scrambling for your calculator so you can see where the absolute max and min is. But the point of this is to do this without a calculator, to find out what we can figure out using analysis. So let's do this. I know I'm going to be needing to take a derivative. An absolute value is just kind of atrocious. So what I can say is, let's see, we're looking at this between -5 and 1. And what I know is that between -3 and 3, the value of what I have inside is going to change. So let's see. So I want to find what's going on in the interval to the left of -3. And if I'm taking something to the left of -3, well, then I know that what's inside that absolute value is going to be negative. So I'm going to need to, if I take the absolute value away, take the opposite. So I'm going to rewrite this in piecewise form. So if x is going to be less than -3, less than or equal to, this is going to become 1 minus -9 minus x squared. And I'm going to clean that up in a minute. For x between -3 and 1, well, between -3 and 1, what I end up inside the square root is going to be positive anyway. So I just can disregard the absolute value, 1 minus 9 minus x squared. So let's tidy this up. So our function really is, let's see, for x less than 3, this is going to be 10 minus x squared. And for x between -3 and 1, so this is x less than or equal to -3. And for x between -3 and 1, this is going to give us -8 plus x squared. And I know that if I plug in a -3, that's going to give me a 1 on both sides. So this is continuous. Okay, so let's find the derivative. And our derivative for the first part is going to be -2x if x is less than or equal to -3. For the top part, it's going to be 2x if x is greater than -3. If I was going to set this derivative equal to 0, that would give me x is equal to 0, which is not in this domain. If I was going to set this equal to 0, it would give me x is equal to 0, which is in this domain. So I'm going to have a critical value at x is equal to 0 in here. And I also am observing that f prime of x, let's look at the fact that this is a piecewise function. If I look for the limit as x approaches -3 from the right of this derivative, -3 from the right, that's going to give us a -6. But if I look at the limit as x approaches -3 from the left for this derivative, right, that's going to give me a +6. So this is not continuous, so f prime of -3 does not exist. So hence we have another critical value at x is equal to -3. Okay, so let's do our work. Let's test our endpoints. F of -5 is going to give us 1 minus 9 minus 25 is 16, and we're just going to take the absolute value of -16. So that's going to give me a -15. If I plug a 1 in, that's going to give me 1 minus the absolute value of 8, which is 8, which is -7. If I plug a 0 in, that's going to give me just 1 minus 9. If I plug a -3 in, that's going to give me 1 minus 0, so that's 1. So here's my competition. So I know that our absolute minimum value is right here. And that happens at the left endpoint. I know the absolute max is 1, and that happens at x is equal to -3.